Geology is the branch of earth science that deals with the study of the solid earth, its materials, and the processes that shape it over time. It encompasses the investigation of Earth's composition, structure, history, and the mechanisms responsible for geological change. Its importance is important in understanding natural hazards like earthquakes, landslides, volcanoes. Important in locating natural resources like minerals, oil, groundwater. It's important in interpreting Earth's history and evolution. It's important in planning sustainable land use and environmental management. Major branches of geology. Physical geology. It studies earth materials and processes like the erosions, sedimentation, volcanism. Historical geology. It examines Earth's past using rock records and fossils. Petrology. It studies rocks, their origin, structure, and mineral content. Mineralogy. The study of minerals, their chemistry, crystal structure, and physical properties. Structural geology. It analyzes rock deformation, that's in folds, faults, stress patterns. Sedimentology studies the sedimentary processes and deposits. Paleontology is the study of fossils to understand past life and environment. Geochemistry, the chemical composition of the earth materials and processes. Geomorphology, the study of landforms and surface processes shaping them. Volcanology and seismology is the study of volcanoes, earthquakes, and related phenomena. Rock science, also known as petrology. Rocks are naturally occurring aggregates of minerals and are classified into three major types based on their origin. We have igneous rocks. These are rocks born of fire. They are formed from the solidification of molten magma or lava. You can classify them into intrusive or plutonic. These are slow cooling underground large crystals like granite or diorite. Then we have extrusive or volcanic, and these are rapid cooling at surface fine crystals. Examples being basalt and pumice. Key examples of igneous rocks. We have quartz, feldspar, mica, pyroxene. Sedimentary rocks. These are rocks of records of the past. They are formed by the accumulation and lithification of sediments. The types, we have clastic, sandstone or shale, and then we have chemical, limestone, rock salt, and then we have organic, which could be coal, chalk. These sedimentary rocks contain fossils and past climate data. They host significant oil, gas, and groundwater reservoirs. Metamorphic rocks. These are changed form rocks. They are formed when pre-existing rocks are transformed by heat, pressure, or chemical processes without melting. The types, we have foliated, example being schist, gneiss. Non-foliated, we have marble, quartzite. Let's look at the processes. Contact metamorphism, heat from nearby magma. And we have regional metamorphism, mountain building pressures. The rock cycle. The rock cycle explains how igneous, sedimentary, and metamorphic rocks transform into one another over geological time through processes like melting, cooling, weathering, erosion, and metamorphism. Mineralogy. A mineral is a naturally occurring inorganic solid with a definite chemical composition and an ordered atomic structure. Properties. They are naturally occurring, they are inorganic, They are crystalline and they have definite composition. Physical properties of minerals: its color, visible hue, though not always diagnostic. The streak, that's the color of the powdered form. Luster, metallic, vitreous, dull. Hardness, that's resistance to scratching. Cleavage, that's the tendency to break along flat planes. Fracture, irregular breakage pattern. Specific gravity, as the density of this rock or mineral relative to water. And a crystal form, a shape determined by atomic arrangement. Major mineral groups: we have silicates. These are the largest group, examples being quartz, feldspar, mica. We have carbonates, CO3 group, example being calcite, dolomite. We have the oxides, oxygen with metals. We have the hematite and magnetite. We have the sulfides, that's sulfur with metals, which is the pyrite and the galena. Sulfates, SO4 groups, example being the gypsum and hydrite. Halides, that's the halogen elements. We have halite and fluorite. Then we have native elements, that's pure elements, being gold, copper, diamond. Importance of minerals: the economic value, ores for metals, gemstones. Industrial uses, they are used in building materials, electronics, and fertilizers. Scientific value, they are indicators of geological conditions and processes. Let's look at some geology in the society.